Welcome to This Explainer. Today, we're diving straight into the hidden and honestly pretty incredible life cycle of our water. We're using sustainability metrics pulled directly from the SASB Water Utilities and Services Standard to uncover how this massive industry really works. We're going to look at the whole shebang: sourcing, treatment, distribution to homes and businesses, and then where it all goes: the collection and treatment of our wastewater.
But first, I want you to just stop and think for a second. Do you actually know what it takes to get that water to your tap and where it ends up after it swirls down your drain? We just turn on the faucet and expect clean water instantly, right? But behind that really simple action is literally one of the most complex, energy-intensive, and highly regulated networks on the planet.
So here's how we're going to break this life cycle down today. 4 steps. 1. Sourcing. 2. Distribution. 3. Consumption. And 4. Treatment. That's our roadmap.
Kicking things off with Phase 1, sourcing and supply resilience.
There is an incredible diversity in where our water actually comes from. Utilities are pulling from groundwater, surface water, so your rivers, lakes, and oceans, recycled water, and even buying it wholesale from third parties. But here's the absolute kicker that the SASB standards highlight. Utilities have to track exactly how much of this fresh water comes from regions facing high or extremely high baseline water stress. It's a huge metric because if you're continually drawing from stressed regions, you're fundamentally threatening your long-term supply resilience. And water stress isn't the only headache here. Utilities are facing a real gauntlet of environmental risks. We're talking climate change, severe weather events, overconsumption by competing users, and source contamination. To actually survive all this, utilities can't just sit back. They have to proactively manage these risks with serious contingency planning, securing senior water rights, and absolutely prioritizing the diversification of their sources. You definitely do not want to be totally dependent on just one vulnerable aquifer.
Moving right along to Phase 2, treatment and distribution.
So, withdrawing, moving, and treating all this water, it takes a staggering amount of electricity. As you'll find in the standards right after purchasing the water itself, chemicals, and labor, energy use is typically a utility's absolute largest operating cost. No joke. This is exactly why total energy consumed, and specifically how much of that is grid electricity versus renewables, is such a critical sustainability metric. If a utility isn't energy efficient, their costs just completely skyrocket and their greenhouse gas emissions go right up with them.
Now, here's where things get kind of mind-boggling. Listen to this industry term, non-revenue real water losses. Okay, it sounds super bureaucratic, but it actually reveals a massive, hidden inefficiency. This is physical water that is completely lost from the pressurized system, mostly just leaking out of aging pipes and broken service connections long before it ever even reaches a customer's meter. It generates zero revenue, it completely wastes the energy and chemicals used to treat it, and it constantly forces utilities to spend big bucks digging up and replacing old water mains.
All right, Phase 3, affordability and end use.
So, who's actually using all this water? Utilities generally serve 3 main slices of the pie: residential, commercial, and industrial customers. And things like average retail rates and efficiency requirements, they vary wildly across these groups. Understanding this breakdown is absolutely vital because rate structures have to be carefully tailored to ensure fair access for everyone, while still bringing in enough cash to keep the infrastructure from literally falling apart. Which brings us to a really sensitive but critical piece of the puzzle: affordability. Reliable, clean water is a basic human right. So to track affordability, utilities are required to measure the number of residential water disconnections for non-payment, as well as the percentage that get reconnected within 30 days. They have to look at the big picture, evaluating how prevailing economic conditions and local poverty rates directly impact a customer's ability to afford this essential service. But wait a second, utilities are also supposed to promote water conservation, right? So how do they tell people to use less water without bankrupting themselves from the lost sales? Well, enter this brilliant mechanism: revenue decoupled rate structures. Essentially, this completely separates the utility's fixed cost recovery from the actual volume of water they sell. It guarantees the utility collects the revenue it needs based on regulatory requirements, which then frees them up to aggressively and financially incentivize their customers to conserve water. It's a real game changer.
All right, pivot time. Phase 4, wastewater and climate resilience.
Because once we use the water, it all goes down the drain. Collecting this wastewater, and we're talking sewage, greywater, industrial fluids, and even stormwater runoff, requires massive treatment facilities, and climate change is putting them right in the crosshairs.
Utilities have to track exactly how much of their critical wastewater treatment capacity sits squarely inside vulnerable 100-year flood zones. With rising sea levels and increasingly severe weather, these facilities, especially the ones in low-lying areas, are facing a very real threat of catastrophic failure. And when those severe storms do hit, we face the really harsh reality of SSOs, sanitary sewer overflows. When a massive amount of intense precipitation infiltrates the system, it can completely overwhelm the treatment plant's capacity. So to stop the entire system from backing up, utilities are sometimes forced to release or divert raw, untreated sewage directly into the environment. It's an awful situation, but tracking the number and volume of these overflows is a crucial indicator of just how resilient the network actually is.
And that leads us to our final step, Phase 5, managing effluent quality. Assuming the wastewater makes it to the facility safely, it has to be rigorously treated before it can be discharged back into nature. But this process is under intense new regulatory scrutiny, mainly because of what we're washing down our drains right now. Utilities are scrambling to manage effluents of emerging concern. We're talking about unregulated substances, pharmaceutical residues, personal care products, flame retardants, endocrine disruptors. Consumers and regulators are, understandably, super worried about these invisible contaminants slipping right through the treatment plants and into our surface waters. So, utilities basically have two primary strategies to tackle these new threats. First, a hazard-based approach. This looks strictly at the toxicological traits of a substance, basically asking, is this chemical toxic, regardless of the actual dosage in the water? On the flip side, a risk-based approach assesses the actual probability of harm. It looks at real-world exposure levels, factoring in how often, and how much of it the population is actually exposed to. Utilities have to strategize using both of these approaches to deploy advanced treatment tech before new regulations catch them totally off guard.
So what does this all mean? The biggest takeaway here is that this massive, invisible utility operation is directly, intimately tied to your everyday life. From the stressed aquifers, where the whole journey begins, to the leaking pipes under your street, the rate structures on your bill, and the intense treatment of the wastewater leaving your home. It really makes you wonder, what effluents of emerging concern are you washing down your own drain today? Think about that the next time you turn on the tap. Thanks for joining me on this explainer, and keep learning.